The universe is unimaginably vast, stretching beyond the limits of our comprehension. For centuries, humanity has dreamed of exploring the stars, of venturing beyond our tiny corner of the cosmos. But here's the catch: space is so enormous that even the fastest spacecraft would take thousands of years to reach the nearest stars. What if there was a way to bypass those immense distances entirely? Enter wormholes, hypothetical tunnels through space-time that could act as cosmic shortcuts, revolutionizing the way we travel the universe. Imagine stepping through a doorway and emerging on the other side of the galaxy in the blink of an eye. Sounds like science fiction, maybe, but what if it's not? In this video, we'll dive into 20 groundbreaking theories on how wormholes could make interstellar travel a reality. From faster-than-light journeys to connections between parallel universes, these ideas could change everything we know about space exploration. So buckle up, because we're about to take a mind-bending trip through the possibilities of wormholes and the incredible future they might unlock for humanity. Ready to explore the unknown? Let's go. Now, let's dive into our first theory: wormholes as cosmic shortcuts. Imagine the universe as a vast sheet of paper with galaxies and stars scattered across its surface. Traveling from one point to another would normally require moving across the entire sheet. But what if you could fold the paper, bringing those 2 points closer together? That's the essence of a wormhole, a theoretical tunnel through space-time that creates a shortcut, drastically reducing the distance between 2 locations. This idea isn't just science fiction. It's rooted in Einstein's theory of general relativity, which describes how massive objects like stars and planets warp the fabric of space-time. Wormholes, also known as Einstein-Rosen bridges, are essentially bridges connecting 2 different points in this curved space-time. If they exist, they could allow us to traverse the universe in a fraction of the time it would take with conventional space travel. But here's the catch: while Einstein's equations suggest wormholes are possible, they're incredibly unstable and would require exotic matter with negative energy to stay open. Even so, the concept of wormholes as cosmic shortcuts opens up a tantalizing possibility. What if humanity could one day use these tunnels to explore the farthest reaches of the cosmos? It's a mind-bending idea that could redefine our understanding of space and time. Now, turning to the next theory, let's explore how wormholes might enable faster-than-light travel without breaking the laws of physics as we understand them. At first glance, the idea of traveling faster than light seems impossible, given that Einstein's theory of relativity sets the speed of light as the ultimate speed limit in the universe. But wormholes offer a fascinating workaround. Instead of moving through space at speeds that exceed light, wormholes would allow us to bypass space entirely by creating a shortcut through space-time itself. Picture this: if you're on one side of a mountain and need to get to the other side, you could either go around it, which takes time, or tunnel straight through it, significantly reducing the journey. Wormholes work on a similar principle, but on a cosmic scale. They could potentially connect 2 distant points in the universe, enabling us to travel vast distances in a fraction of the time it would normally take, even if those points are light years apart. This doesn't violate relativity because we're not technically moving faster than light. We're simply taking a shortcut. The hypothetical mechanisms behind this involve the warping of space-time, which could create a stable pathway between 2 locations. However, this would likely require exotic matter or negative energy to keep the wormhole open and navigable. If such a feat were possible, the implications for space travel would be revolutionary, opening up the possibility of exploring distant galaxies, establishing interstellar colonies, or even encountering alien civilizations. It's a concept that challenges our understanding of physics and pushes the boundaries of what we thought was possible. Now, shifting our focus to the next intriguing idea, let's explore how wormholes could offer an explanation to one of the most puzzling questions in astronomy: the Fermi Paradox. This paradox asks, if the universe is so vast and filled with potentially habitable planets, why haven't we detected any signs of intelligent extraterrestrial life? One possible answer lies in the nature of wormholes. Imagine if advanced civilizations had already mastered the use of wormholes as a means of interstellar travel. Instead of traversing the galaxy in conventional ways, which might leave detectable traces like radio signals or spacecraft, they could be using wormholes to move silently and efficiently across the cosmos. This would make their presence nearly invisible to us, as they wouldn't need to emit the kind of signals we're actively searching for. Wormholes could act as hidden highways, allowing these civilizations to explore, colonize, or communicate without ever revealing their existence to less advanced species like us. Furthermore, if wormholes connect distant parts of the universe, it's possible that these advanced beings are operating in regions far beyond our current observational reach. This theory also suggests that the absence of contact doesn't necessarily mean the absence of life. It could simply mean that we're not yet equipped to detect their methods of travel or communication. By considering wormholes as a solution to the Fermi Paradox, we open up a fascinating new perspective on the search for extraterrestrial intelligence, one that challenges us to rethink how we look for signs of life in the universe. As we delve deeper into this idea, it becomes clear that wormholes might not just revolutionize space travel, they could also reshape our understanding of life beyond Earth. Now, as we venture into the next layer of this cosmic puzzle, let's turn our attention to the immense energy requirements involved in creating or stabilizing a wormhole. The idea of bending space-time to form a tunnel between distant points is undeniably captivating, but it comes with a significant hurdle: the sheer amount of energy needed to make it possible. According to current theoretical physics, wormholes would require not just a large amount of energy, but a very specific kind of energy, exotic matter or negative energy. Unlike the ordinary matter we're familiar with, exotic matter possesses properties that defy our everyday understanding, such as negative mass or the ability to repel rather than attract. This strange substance would be essential to counteract the natural tendency of wormholes to collapse under their own gravitational forces. Without it, a wormhole would likely snap shut almost instantly, making it useless for travel. But here's the catch: exotic matter has never been observed in nature, and creating it in a lab remains a monumental challenge. Scientists speculate that harnessing such energy might involve technologies far beyond our current capabilities, such as manipulating quantum fields or tapping into the energy of entire stars. And even if we could achieve this, the question remains: how much energy would it actually take? Some estimates suggest that the energy required could be equivalent to the output of a neutron star or even a black hole, making it a staggering feat of engineering. This brings us to the concept of negative energy, a theoretical form of energy that could help stabilize a wormhole by counteracting its instability. While negative energy remains speculative, its existence is not entirely ruled out by the laws of physics, particularly when we consider phenomena like the Casimir effect in quantum mechanics. As we explore these ideas, it's clear that the energy requirements for wormhole creation are not just a technical challenge. They're a fundamental barrier that pushes the boundaries of our understanding of physics. But they also offer a tantalizing glimpse into the possibilities that could await us if we ever unlock the secrets of exotic matter and negative energy. The road to creating a wormhole may be long and fraught with obstacles, but the potential rewards could redefine our place in the universe. Now, shifting our focus to a truly mind-bending concept, let's explore the idea of wormholes as potential time machines. Imagine stepping through a wormhole not just to reach a distant star, but to arrive in a different point in time, whether it's the distant past or the far future. This isn't just science fiction, it's a possibility deeply rooted in the principles of space-time curvature and causality. According to Einstein's theory of general relativity, the fabric of space-time can be warped by massive objects, creating pathways that could theoretically allow for time travel. A wormhole, acting as a shortcut through this curved space-time, could potentially connect not only distant locations but also different moments in time. But how exactly would this work? The key lies in the concept of time dilation, where time passes differently depending on the strength of gravity or the speed at which you're moving. If one end of a wormhole were exposed to extreme gravitational forces or accelerated to near light speeds, time would slow down for that end relative to the other. This would create a time difference between the two ends of the wormhole, effectively turning it into a bridge between past and future. For example, if you entered one end of the wormhole after it had experienced time dilation, you could emerge from the other end at a point in time before you even entered. However, this raises fascinating and complex questions about causality, the relationship between cause and effect. If time travel were possible, could you alter events that have already happened? And if so, what would that mean for the flow of time itself? These questions lead to paradoxes like the famous grandfather paradox, where a time traveler might prevent their own existence by altering the past. While these ideas are thrilling, they also highlight the profound challenges and mysteries surrounding wormholes and time travel. The interplay between space-time curvature, causality, and the laws of physics suggests that if wormholes could indeed enable time travel, they would also force us to rethink our understanding of the universe. As we continue to explore this theory, one thing is clear. The possibility of wormholes as time machines not only expands our horizons but also challenges us to confront the deepest questions about the nature of time itself. Now shifting our perspective to the microscopic realm, let's delve into the intriguing connection between quantum mechanics and wormholes. While wormholes are often discussed in the context of Einstein's general relativity, quantum mechanics introduces a whole new layer of possibilities. At the quantum level, particles behave in ways that defy classical physics, and these behaviors might hold the key to understanding wormholes. One of the most fascinating concepts here is quantum entanglement, where two particles become linked in such a way that the state of one instantly influences the other, regardless of the distance between them. This phenomenon, often dubbed spooky action at a distance, has led some scientists to speculate that entangled particles could be connected by microscopic wormholes. In fact, theoretical models suggest that these tiny wormholes might explain how entangled particles communicate faster than the speed of light without violating the laws of physics. This idea bridges the gap between quantum mechanics and general relativity, two frameworks that have historically been difficult to reconcile. But the role of quantum mechanics doesn't stop there. It also raises questions about the stability of wormholes. In classical physics, wormholes are thought to be highly unstable, collapsing almost immediately after forming. However, quantum effects such as the presence of exotic particles or energy fluctuations might provide the necessary conditions to keep a wormhole open long enough for travel or observation. For instance, quantum tunneling, a phenomenon where particles pass through barriers they shouldn't be able to, could offer insights into how wormholes might persist in nature. Additionally, the concept of a quantum foam, where spacetime is thought to be constantly bubbling with tiny wormholes and black holes at the smallest scales, adds another layer of intrigue. This quantum foam suggests that wormholes might be far more common than we realize, existing everywhere in the universe but at sizes too small to detect with current technology. As we explore these ideas, it becomes clear that quantum mechanics doesn't just complement our understanding of wormholes, it could fundamentally transform it. By blending the bizarre behaviors of the quantum world with the grand scale of spacetime, we might unlock new pathways to make wormholes a reality. This intersection of quantum mechanics and wormholes not only pushes the boundaries of science, but also invites us to reimagine the very fabric of the universe. As we continue to explore these theories, one thing is certain: the quantum realm holds secrets that could revolutionize our understanding of wormholes and their potential for space travel. Now turning to the intriguing relationship between black holes and wormholes, we find ourselves at the crossroads of two of the universe's most mysterious phenomena. Black holes, with their immense gravitational pull that not even light can escape, have long captured our imagination. Wormholes, on the other hand, are often imagined as cosmic shortcuts, bending the fabric of space-time to connect distant points in the universe. But could these two concepts be more connected than we think? Some scientists theorize that black holes might serve as natural entrances to wormholes, offering a potential gateway to other regions of the cosmos or even other universes. This idea stems from the way both black holes and wormholes distort spacetime. In the case of a black hole, the extreme curvature of spacetime leads to an event horizon, a point of no return where matter is pulled inexorably toward the singularity at its center. Wormholes, however, are thought to create a bridge between 2 points in spacetime, potentially allowing matter to pass through without being destroyed. The question is, could the intense gravitational forces of a black hole be harnessed to stabilize a wormhole? One theory suggests that certain types of black holes, particularly those that rotate or are electrically charged, might create conditions that allow a wormhole to form. These black holes could theoretically produce a throat in spacetime, connecting to another black hole or a distant region of the universe. However, the physics behind this idea is incredibly complex. For a wormhole to remain traversable, it would require exotic matter or negative energy to counteract the immense gravitational forces that would otherwise cause it to collapse. This is where the connection between black holes and wormholes becomes both fascinating and challenging. While black holes might provide the conditions for a wormhole to exist, keeping it stable would require technologies and materials far beyond our current understanding. Despite the challenges, the idea of black holes as wormhole entrances has profound implications for space travel. If such a connection could be proven or even manipulated, it could open up entirely new possibilities for exploring the universe. Imagine stepping into a black hole and emerging light years away in an instant, bypassing the limitations of traditional space travel. While this remains firmly in the realm of theory, the exploration of this connection continues to push the boundaries of our understanding of physics. As we delve deeper into the mysteries of black holes and wormholes, we find ourselves on the edge of discovery, where the line between science fiction and scientific possibility becomes increasingly blurred. Now shifting our perspective to the realm of imagination versus science, let's explore how wormholes have been depicted in science fiction and how those portrayals compare to the real-world theories we've been discussing. Science fiction has long been a playground for wild and creative ideas, and wormholes are no exception. From blockbuster movies to best-selling novels, they've been portrayed as convenient gateways to distant galaxies, time travel devices, or even plot devices for epic adventures. Think of iconic scenes where characters step through a glowing portal and emerge in a completely different world, often with little explanation of the physics behind it. While these depictions are thrilling and visually stunning, they often take liberties with scientific accuracy to serve the story. In reality, the concept of wormholes is grounded in the complex mathematics of general relativity, a far cry from the straightforward, user-friendly portals we see on screen. Real-world wormholes, if they exist, would require extraordinary conditions to form and stabilize. They'd likely be incredibly small, unstable, and filled with challenges like extreme tidal forces and the need for exotic matter. Compare this to the cinematic version, where wormholes are often large, stable, and ready to transport entire starships across the universe. Another key difference is the way wormholes are accessed. In science fiction, characters often stumble upon wormholes accidentally or activate them with simple technology. In reality, creating or finding a wormhole would require advanced knowledge of physics and engineering far beyond our current capabilities. Plus, the idea of traversing a wormhole without being torn apart or encountering insurmountable obstacles is still purely theoretical. That said, science fiction serves an important purpose. It sparks curiosity and inspires real-world scientific inquiry. Concepts like wormholes, once confined to the pages of novels or the frames of movies, have motivated physicists to explore the boundaries of what's possible. While there's a clear gap between the wormholes of fiction and the wormholes of reality, this gap also highlights the power of imagination in driving innovation. After all, today's science fiction could be tomorrow's science fact. As we continue to explore the mysteries of wormholes, we're reminded that the line between imagination and reality is often thinner than we think. Now venturing into the realm of the unknown, let's consider how wormholes might open doors to more than just distant corners of our universe. What if they could serve as bridges to entirely different universes? This idea ties into the multiverse theory, a fascinating concept in cosmology that suggests our universe might just be one of many. Imagine wormholes as cosmic tunnels, not only connecting points within our universe, but also linking us to parallel worlds with their own unique laws of physics, stars, and perhaps even life. The implications for space travel are mind-bending. Instead of exploring just our galaxy, wormholes could theoretically allow us to step into alternate realities, expanding the boundaries of human exploration in ways we can barely comprehend. However, this concept isn't without its challenges. For one, the existence of a multiverse is still a highly debated topic in physics. While some theories, like string theory and quantum mechanics, support the idea of multiple universes, there's no direct evidence to confirm their existence. Even if wormholes could connect universes, the journey itself would be fraught with uncertainties. How would the laws of physics differ in another universe, and how would we adapt to them? And what if the wormhole leads to a universe that's inhospitable or incompatible with life as we know it? Despite these questions, the idea of wormholes as gateways to the multiverse sparks excitement and curiosity. It pushes us to rethink our understanding of reality and challenges us to dream bigger. If wormholes could indeed connect universes, they'd not only revolutionize space travel, but also our understanding of existence itself. As we continue to explore the mysteries of wormholes, the multiverse theory reminds us that the cosmos might be far more vast and interconnected than we ever imagined. Now shifting our focus to the practical side of wormhole travel, let's explore the challenges that come with navigating these cosmic tunnels. While the idea of zipping across the universe in an instant is thrilling, the reality of traversing a wormhole is fraught with significant risks. One of the most immediate dangers is the presence of tidal forces. These forces, caused by the intense gravitational pull within a wormhole, could stretch and compress anything passing through it. Even with advanced technology, the sheer power of these forces could pose a serious threat to both spacecraft and their passengers. Adding to the complexity is the issue of radiation. Wormholes, especially those linked to black holes, are likely to be filled with high-energy radiation. Prolonged exposure could be deadly to humans and damaging to electronic systems. Shielding against such radiation would require materials and technologies far beyond our current capabilities, making it a major hurdle for any mission attempting to traverse a wormhole. Then there's the ever-present risk of collapse. Wormholes, as described by current theories, are inherently unstable. Without some form of exotic matter or negative energy to keep them open, a wormhole could collapse at any moment, trapping or destroying anything inside. Even if we could stabilize a wormhole, maintaining it for long durations would be a monumental challenge. The unpredictability of their structure adds another layer of uncertainty to the equation. Beyond these physical dangers, there's also the question of navigation. How would we ensure that a wormhole leads to the intended destination? Unlike traveling through familiar space, wormholes could transport us to unknown regions of the universe where the environment might be hostile or completely incompatible with life. Without reliable mapping or control mechanisms, the journey could quickly turn into a one-way trip into the unknown. While these challenges might seem daunting, they also highlight the ingenuity and determination required to make wormhole travel a reality. Overcoming these obstacles would push the boundaries of human knowledge and technology, opening up possibilities we can only begin to imagine. As we continue to explore these cosmic gateways, the challenges remind us that the path to the stars is never easy, but the rewards could be truly extraordinary. Now, stepping into a new frontier of possibility, let's consider how wormholes could serve as gateways to habitable planets. Imagine a future where instead of spending decades or even centuries traveling to distant star systems, we could step through a wormhole and find ourselves in a new world teeming with potential. These cosmic tunnels could lead us to exoplanets, worlds beyond our solar system, that might possess the right conditions for life or even for human colonization. The search for habitable planets has always been a cornerstone of our quest to understand the universe. With wormholes, this search could take a dramatic leap forward. Instead of relying on telescopes and probes to study distant worlds from afar, we could potentially visit them directly. Picture a planet with lush landscapes, breathable air, and liquid water, elements essential for life as we know it. Wormholes could make such discoveries not just a dream, but a tangible reality. This concept also opens up exciting possibilities for the search for extraterrestrial life. If wormholes connect us to distant regions of the cosmos, they could bring us face to face with other forms of life, perhaps even civilizations far more advanced than our own. The implications are staggering. Not only could we find answers to some of humanity's most profound questions, like whether we're alone in the universe, but we could also establish connections with other intelligent beings. Of course, the idea isn't without challenges. Identifying a wormhole that leads to a habitable planet would require precise mapping and understanding of these cosmic structures. We'd also need to ensure that the environment on the other side is stable and safe for exploration or colonization. Yet, the potential rewards make this a pursuit worth considering. Imagine the scientific breakthroughs, the cultural exchanges, and the new horizons that could emerge from such discoveries. As we ponder the role of wormholes in this cosmic quest, it's clear that they could revolutionize not just space travel, but our entire relationship with the universe. The stars may no longer be out of reach, and the search for life, whether on distant planets or through encounters with other civilizations, could take on a whole new dimension. The journey through wormholes to habitable worlds is a vision of the future that inspires both wonder and determination, reminding us that the universe is full of possibilities waiting to be explored. Now, shifting our gaze to the broader cosmos, let's explore how the accelerating expansion of the universe could influence the practicality of wormholes as a means of interstellar travel. The universe isn't just vast, it's growing larger every second, driven by a mysterious force we call dark energy. This expansion stretches the fabric of space-time itself, and it raises fascinating questions about the stability and accessibility of wormholes over vast cosmic distances. As the universe expands, the distances between galaxies and star systems increase. This means that even if we were to discover or create a wormhole today, the location of its exit point might drift farther away over time. Imagine stepping into a wormhole only to find that its destination has moved millions of light years away by the time you emerge. This cosmic drift could complicate the use of wormholes for travel, requiring constant recalibration or even rendering them obsolete over long periods. But here's where things get even more intriguing. Some theories suggest that the expansion of the universe could actually stabilize certain types of wormholes. The stretching of space-time might counteract the forces that cause wormholes to collapse, making them more durable and potentially easier to traverse. This would be a game-changer, allowing us to harness the universe's expansion as a tool rather than an obstacle. However, there's a catch. the acceleration of the universe's expansion isn't uniform, it varies across different regions of space. This means that the behavior of wormholes could differ depending on their location and the local rate of expansion. Navigating these variables would require advanced technology and a deep understanding of cosmic physics, adding another layer of complexity to the challenge. Despite these challenges, the interplay between wormholes and the universe's expansion opens up a wealth of possibilities. It invites us to think creatively about how we might adapt to the ever-changing cosmos. Could we develop technologies to counteract cosmic drift? Or might we find ways to use the expansion to our advantage, turning it into a tool for exploration rather than a barrier? As we ponder these questions, one thing is certain: the universe's expansion adds a dynamic dimension to our understanding of wormholes. It reminds us that space isn't static, it's a living, evolving entity. And if we're to unlock the full potential of wormholes, we'll need to embrace this complexity, using the universe's own mechanisms to guide our journey through the stars. Now turning to the fascinating role wormholes could play in communication, let's explore how these cosmic tunnels might revolutionize the way we send and receive information across the universe. Imagine a scenario where messages, data, and even entire conversations could be transmitted instantaneously across light years of space, bypassing the limitations of traditional methods. This could transform not only scientific research but also the way civilizations connect. The primary challenge with interstellar communication today is the sheer scale of distances. Even at the speed of light, a message sent from Earth to the nearest star system, Proxima Centauri, would take over 4 years to arrive. Wormholes, however, could act as shortcuts, allowing information to travel vast distances in a fraction of the time. This would enable near-instantaneous communication, bridging the gaps between star systems and making interstellar dialogue a reality. But how exactly would this work? One idea is that wormholes could function as quantum channels, preserving the integrity of information as it travels through space-time. Quantum entanglement, a phenomenon where particles remain connected regardless of distance, might play a key role here. By linking entangled particles through a wormhole, we could theoretically transmit data without degradation or delay, creating a seamless interstellar network. There's also the possibility of using wormholes to send physical objects like data drives or even small probes that carry information across the cosmos. This would be especially valuable for transmitting complex data sets or cultural artifacts that cannot be easily digitized. The implications for scientific collaboration, cultural exchange, and even diplomacy are immense. However, this idea isn't without its challenges. Stabilizing a wormhole for communication purposes would require immense energy and precise control. Ensuring that the transmitted information remains secure and free from interference would also be critical. And then there's the question of accessibility. Would wormholes be reserved for governments and scientists, or could they become a public resource for interstellar communication? Despite these hurdles, the potential benefits are staggering. Wormholes could allow us to share knowledge, ideas, and discoveries with civilizations light years away, fostering a sense of unity across the cosmos. They could also help us detect and communicate with extraterrestrial intelligence, should it exist, opening the door to unprecedented collaboration. As we consider the possibilities, one thing becomes clear: wormholes aren't just about travel, they're about connection. By transforming the way we communicate, they could bring us closer to the stars and to each other, redefining what it means to be an interstellar species. This vision invites us to think beyond the limitations of our current technologies and imagine a future where the universe is just a conversation away. Shifting our focus to the intriguing relationship between wormholes and time, let's delve into how these cosmic phenomena could fundamentally reshape our understanding of the arrow of time. Time, as we experience it, flows in one direction from past to future, but wormholes, with their ability to bend space-time, might offer a way to challenge this unidirectional flow, opening up possibilities that blur the lines between past, present, and future. One of the most compelling ideas is that wormholes could act as gateways not just through space, but also through time. According to theoretical physics, a wormhole could connect 2 points in spacetime that are separated by both distance and time. This means that entering a wormhole in one location and era could result in exiting in another, potentially allowing for backward or forward time travel. Such a concept raises profound questions about causality, the relationship between cause and effect, and whether altering the past could impact the future. The classic example of this is the grandfather paradox. If you were to travel back in time and prevent your grandfather from meeting your grandmother, you would never be born, creating a logical contradiction. Wormholes, if they could facilitate such journeys, would force us to rethink the very nature of reality. Could the universe have built-in mechanisms to prevent such paradoxes, or would alternative timelines emerge to accommodate these changes? These are questions that physicists and philosophers continue to grapple with. Another fascinating aspect is how wormholes might interact with the arrow of time in the context of entropy, the measure of disorder in a system. Entropy is often cited as the reason time flows in one direction. It increases over time, creating the distinction between past and future. If wormholes allow for time travel, could they also enable the reversal of entropy? The implications of such a possibility are staggering, ranging from the potential to undo aging to the ability to restore degraded systems. However, the challenges are immense. Creating or traversing a wormhole that connects different points in time would require immense energy and a level of technological sophistication far beyond our current capabilities. Moreover, the stability of such a wormhole is questionable. Any attempt to use it for time travel could disrupt its structure, potentially causing it to collapse. These hurdles make the idea of time travel through wormholes a tantalizing yet elusive prospect. As we explore these possibilities, it's clear that wormholes don't just challenge our understanding of space, they also push the boundaries of time itself. By questioning the arrow of time and the nature of causality, they invite us to rethink some of the most fundamental aspects of our universe. Whether or not we ever achieve the ability to traverse time, the mere possibility expands our imagination and deepens our curiosity about the cosmos. Now, let's shift our gaze from the natural mysteries of wormholes to the extraordinary potential of human ingenuity. Imagine a future where we don't just wait for the universe to provide wormholes, instead, we create them ourselves. This is the realm of artificial wormholes, a concept that blends cutting-edge science with the limitless ambition of humanity. The idea of crafting a wormhole from scratch might sound like science fiction, but it's grounded in real theoretical physics. To create an artificial wormhole, we would need to manipulate space-time on an unprecedented scale. One of the key challenges is finding a way to generate and sustain the exotic matter or negative energy required to keep a wormhole stable. Exotic matter, with its unusual properties like negative mass, would counteract the natural tendency of a wormhole to collapse under its own gravity. The problem: we've yet to discover or produce such matter in meaningful quantities. Another hurdle is the sheer scale of energy involved. Theories suggest that creating even a tiny wormhole could require energy equivalent to that of an entire star. This raises questions about not just the feasibility of such a project, but also the ethical and practical implications of harnessing that much power. Could future advancements in energy production, like harnessing antimatter or mastering zero-point energy, provide the solution? It's a tantalizing thought, but one that remains firmly in the realm of speculation for now. Engineering an artificial wormhole would also demand breakthroughs in materials science. The structures needed to contain and stabilize a wormhole would have to withstand unimaginable stresses, from extreme gravitational forces to the potential for quantum instability. Think of it as building the ultimate cosmic bridge, one that doesn't just span vast distances, but also navigates the complexities of space-time itself. Despite these challenges, the potential rewards are staggering. An artificial wormhole could revolutionize space travel, turning what is now a journey of generations into a matter of moments. It could open up new frontiers for exploration, colonization, and even commerce, connecting distant parts of the universe in ways we can barely imagine. And beyond practical applications, the mere act of creating a wormhole would be a testament to human creativity and determination, a reminder that we are capable of reshaping the cosmos itself. Of course, this raises questions about the responsibility that comes with such power. How would we regulate the use of artificial wormholes? What safeguards would be needed to prevent misuse or unintended consequences? These are questions that future generations will need to grapple with as they push the boundaries of what's possible. As we consider the prospect of artificial wormholes, one thing is clear: they represent not just a scientific challenge, but a bold vision of what humanity could achieve. Whether or not we ever succeed in creating one, the pursuit of this idea pushes us to think bigger, dream bolder, and explore the furthest reaches of our potential. And in that pursuit, we may discover not just new ways to traverse the universe, but new ways to understand ourselves. Now turning to a pressing issue that affects us all: resource scarcity. Imagine a world where we're no longer limited by the finite resources of our planet, but instead have access to the vast riches of distant stars and galaxies. This is where wormholes could play a transformative role. By acting as cosmic gateways, they could open up entirely new avenues for securing the materials and energy we need to sustain and advance our civilization. Take asteroid mining, for example. Asteroids are rich in precious metals like platinum, gold, and rare earth elements that are crucial for modern technology. But reaching these asteroids with current technology is incredibly costly and time-consuming. A wormhole could serve as a direct route, allowing us to extract these resources efficiently and bring them back to Earth. This could revolutionize industries from electronics to renewable energy, and reduce our dependence on environmentally damaging mining practices here on our planet. Energy scarcity is another critical challenge we face. Wormholes could provide access to distant star systems where energy sources like solar power or even exotic forms of energy production could be harnessed. Imagine setting up massive solar arrays around a star in another galaxy, transmitting that energy through a wormhole and powering entire cities on Earth. This could solve our energy needs in ways that are both sustainable and scalable. Beyond Earth, wormholes could also enable the colonization of resource-rich planets. If we discover a planet with abundant water, minerals, or even habitable conditions, a wormhole could make it feasible to establish colonies and transport resources back to Earth. This would not only alleviate resource scarcity, but also open up new opportunities for human expansion and survival. Of course, the ethical and logistical challenges of such endeavors cannot be ignored. How would we regulate the extraction of resources from other planets or galaxies? What safeguards would be in place to ensure these activities don't harm alien ecosystems if they exist? These are questions that future generations will need to address as they explore the possibilities of wormhole-enabled resource acquisition. The potential of wormholes to solve resource scarcity is as vast as the universe itself. They offer a vision of a future where humanity is no longer constrained by the limits of our planet, but instead thrives by tapping into the boundless riches of the cosmos. While the technical and ethical hurdles are significant, the rewards could be nothing short of transformative, ushering in an era of abundance and innovation that we can only begin to imagine. Now turning our gaze to the stars, let's explore how wormholes could redefine our search for extraterrestrial intelligence. For decades, humanity has been scanning the cosmos for signs of life, from radio signals to distant biosignatures. Yet, one of the most intriguing possibilities lies in the idea that advanced civilizations might already be using wormholes to traverse the universe undetected by our current methods. This theory suggests that wormholes could be the missing link in our quest to find intelligent life beyond Earth. Think about it. If an alien civilization has mastered the technology to create or stabilize wormholes, they might use them as a means of interstellar travel or communication. Unlike traditional methods of space travel, wormholes would allow them to move vast distances almost instantaneously, leaving little trace of their movements. This could explain why we haven't detected them yet. They're operating in ways that are beyond our current understanding of physics. One fascinating angle is the potential to detect wormhole signatures. If wormholes exist, they might emit unique gravitational waves or energy patterns that we could identify with advanced telescopes and sensors. For instance, the distortion of space-time around a wormhole could create distinct ripples in the fabric of the universe. By searching for these anomalies, scientists might uncover evidence of wormholes, and by extension, the civilizations using them. This approach could also reshape the Fermi Paradox, which questions why we haven't found signs of intelligent life despite the vastness of the universe. If advanced species are using wormholes to bypass traditional space travel, they could be thriving in ways we can't yet observe. Wormholes might not just be cosmic shortcuts, they could also be the key to unlocking the mysteries of extraterrestrial intelligence. Of course, this theory raises its own set of questions. How would we differentiate between natural wormholes and those created by intelligent beings? What kind of technology would we need to detect and analyze these phenomena? And if we did find evidence of an alien civilization using wormholes, how would we communicate with them across such vast distances? While these challenges are significant, the possibility of using wormholes to find extraterrestrial intelligence is a thrilling prospect. It encourages us to think beyond conventional methods and consider the universe's most extraordinary phenomena as clues in our search. As we continue to explore the cosmos, wormholes might just be the breakthrough we need to finally answer one of humanity's oldest questions: are we alone in the universe? Now shifting our focus to the grand cosmic scale, let's delve into how wormholes might influence the ultimate fate of the universe. As we've explored their potential to revolutionize space travel and communication, it's equally fascinating to consider their role in the cosmos's final chapter. Whether it's the Big Crunch, heat death, or another yet-to-be-discovered scenario. Wormholes as gateways through space-time could offer clues or even solutions to some of the most profound questions about how the universe might end. One compelling theory suggests that wormholes could play a part in the Big Crunch hypothesis, where the universe stops expanding and begins to collapse in on itself. In this model, wormholes might act as conduits, funneling matter and energy back toward a singular point, accelerating the process of cosmic contraction. Imagine a vast network of wormholes channeling galaxies, stars, and even light back into a unified, compressed state. This could create a scenario where the universe not only ends but also potentially restarts in a cyclical pattern, with wormholes serving as the threads connecting one cosmic cycle to the next. On the other hand, if the universe is destined for heat death, a slow, cold fading into entropy, wormholes might still have a role to play. In this scenario, they could act as remnants of a once vibrant cosmos, preserving pockets of energy or information long after most of the universe has cooled to absolute zero. Some scientists speculate that these surviving wormholes could become the last vestiges of structure in an otherwise featureless expanse, offering a faint glimmer of order in a universe succumbing to chaos. Another intriguing idea is that wormholes could provide a means of escape or preservation as the universe approaches its end. Advanced civilizations might use them to transport themselves or their knowledge to other regions of spacetime, potentially surviving the universe's demise. This raises profound questions about the resilience of life and intelligence in the face of cosmic destruction. as well as the ethical implications of such actions. Of course, these theories remain speculative, as we still have much to learn about both wormholes and the universe's ultimate fate. However, they highlight the incredible potential of wormholes to reshape our understanding of existence itself. As we continue to explore the cosmos and unravel its mysteries, wormholes might not just revolutionize space travel, they could also hold the key to understanding how the story of the universe concludes. With every discovery, we inch closer to unlocking the secrets of these cosmic phenomena and their role in the grand tapestry of existence. As we venture into uncharted territories, it's essential to consider the ethical implications of using wormholes for space travel. The ability to traverse vast distances or even connect different parts of the universe comes with profound responsibilities. One of the most pressing ethical concerns is the potential impact on alien ecosystems. If we were to discover a habitable planet through a wormhole, how should we approach it? Introducing foreign substances, organisms, or even human presence could unintentionally disrupt or destroy delicate extraterrestrial environments. The idea of being intergalactic stewards raises questions about our duty to protect and preserve life beyond Earth, even if it's vastly different from our own. Another ethical dilemma revolves around the consequences of colonizing new worlds. While wormholes could provide solutions to Earth's resource shortages or overpopulation, we must consider the rights and autonomy of any potential indigenous life forms. Would we have the right to claim and settle these planets, or should we prioritize coexistence and careful study? The history of colonization on Earth serves as a cautionary tale, reminding us of the harm that can arise from imposing our presence on others without consent. Moreover, the very act of creating or manipulating wormholes carries ethical weight. The energy and materials required to stabilize a wormhole could have significant environmental costs on our own planet. Would the benefits of interstellar travel justify the potential harm to Earth's ecosystems? Additionally, the technology needed to create wormholes might be so advanced that it could be weaponized or misused, leading to conflicts on a cosmic scale. Finally, there's the question of who gets to use wormholes. If this technology becomes a reality, access to it could be limited to wealthy nations or corporations, exacerbating global inequalities. Ensuring that the benefits of wormhole travel are shared equitably will be a major ethical challenge, requiring international cooperation and thoughtful policies. These ethical considerations remind us that while wormholes offer incredible possibilities, they also demand careful reflection on our responsibilities as explorers and caretakers of the cosmos. As we push the boundaries of space travel, we must strive to balance innovation with integrity, ensuring that our actions reflect the best of humanity rather than its flaws. Now turning to the final frontier of our exploration, we delve into how wormholes could serve as a unifying force in the realm of physics. The quest to reconcile general relativity and quantum mechanics has long been one of the greatest challenges in science. General relativity describes the universe on a grand scale, governing the behavior of massive objects and the fabric of space-time, while quantum mechanics deals with the minuscule, explaining the behavior of particles at the subatomic level. These two frameworks, though incredibly successful in their own domains, seem incompatible when applied together. Enter wormholes. These cosmic tunnels could potentially offer a bridge between these seemingly conflicting theories. Wormholes, as predicted by general relativity, are intricate structures that bend space-time itself. However, their stability and behavior at the quantum level remain a mystery. Some physicists speculate that wormholes might be governed by quantum mechanics, particularly through phenomena like quantum entanglement, where particles are instantly connected regardless of distance. This intriguing overlap suggests that wormholes could be a key to unlocking a unified theory of physics, blending the large-scale predictions of relativity with the small-scale quirks of quantum mechanics. Moreover, the study of wormholes has sparked new ideas in theoretical physics, such as the holographic principle, which suggests that the information in a volume of space can be represented as a hologram on its boundary. This principle, inspired in part by wormhole research, hints at a deeper connection between spacetime and quantum information. If proven, it could revolutionize our understanding of the universe, showing that spacetime itself might emerge from quantum processes. Wormholes, therefore, aren't just cosmic shortcuts. They could be the key to a deeper, more unified understanding of reality. As we wrap up this journey through 20 groundbreaking theories, it's clear that wormholes hold the potential to transform not only space travel, but also our fundamental understanding of the cosmos. From cosmic shortcuts to time machines, from multiverses to the unification of physics, wormholes challenge us to think beyond the limits of our current knowledge. While many of these ideas remain theoretical, they inspire us to dream big and push the boundaries of what's possible. The future of wormhole research is as vast and mysterious as the universe itself, and who knows what incredible discoveries await us as we continue to explore the unknown. If you've enjoyed this deep dive into the science and possibilities of wormholes, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest explorations of the universe's most fascinating mysteries. Let us know in the comments which theory blew your mind the most. Was it the idea of wormholes as time machines, their role in solving the Fermi Paradox, or their potential to unify physics? Until next time, keep looking up and keep imagining the endless possibilities that lie beyond the stars. As we bring this exploration to a close, let's take a moment to reflect on the incredible possibilities that wormholes present. From serving as cosmic shortcuts that could slash interstellar travel time to potentially enabling faster-than-light journeys, these theoretical structures challenge our understanding of physics and the universe. We've explored how wormholes might explain the Fermi Paradox, connect distant habitable planets, and even serve as portals to other universes. They've inspired discussions on artificial creation, ethical considerations, and their role in the ultimate fate of the cosmos. Each of these 20 theories underscores the transformative potential of wormholes, not just for space travel, but for our entire understanding of reality. They invite us to question the limits of our knowledge and imagine a future where humanity might traverse the stars, harness distant resources, and communicate across galaxies. While many of these ideas remain in the realm of theory, they remind us that the universe is far more mysterious and wondrous than we can currently comprehend. The journey of wormhole research is just beginning, and the possibilities are as vast as the cosmos itself. What if one day we discover that wormholes are not just science fiction but a tangible part of our universe? What if they hold the key to unifying the laws of physics or even preserving humanity's future? These questions drive scientists, dreamers, and explorers to keep pushing the boundaries of what's possible. So, what do you think? Could wormholes be the gateway to humanity's next great adventure? Share your thoughts in the comments below, whether it's your favorite theory, a wild idea of your own, or just your perspective on the future of space travel. Don't forget to like, subscribe, and hit the notification bell so you never miss out on our deep dives into the universe's most fascinating mysteries. Until next time, keep wondering, keep exploring, and keep reaching for the stars. The future is out there, and who knows what incredible discoveries await.